Hello dear learners, I am Dr. Sheena Thomas from the Department of Education at the Bhopal School of Social Sciences. In this module, I would be discussing about a very important topic in mathematics, which is sets. In this module, we will be discussing about the concepts of sets, the representation of sets, types of sets and the operation of sets. So, let us get started. Talking about set, how do you define set? Set basically is defined as a well-defined collection of objects is called as set. Then a very question may arise in the minds of the learners, what is the difference between collection and sets? Let me explain the difference between collection and sets through an example. Like most of you would be having collection of movies, you have collection of games, you have many other collections like force. We say a group of people are standing there, a group of cricketers, a group of sportsmen, so many other things. So, it becomes a collection. But when does a collection become a set? It becomes a set when it is well defined. For example, if a child says that I have got a collection of Marvel series, then in that collection it applies very clearly that that collection becomes a set because it is well defined. You won't find a DC series movies in a collection of Marvel series movies. So, it becomes a set. If you talk about prime numbers, so single digit prime numbers, so the first prime numbers, the single digit prime numbers would be 2, 3, 5, 7. Okay. So, this is well defined. It is a set of prime numbers and the condition applies that it is less than 10 or it is a single digit prime number. So, this makes the difference between collection and sets. This is the prime difference between a collection and a set. So, you have to underline the word well defined. So, a very important point which distinguishes collection from a set is well defined. Okay, that is the most important thing from collection to set. Then how do you denote set? Set is generally denoted by capital letters like A, B, C, D and it goes on, and it is enclosed within curly brackets and the elements are denoted by small alphabets separated by commas. So, it would be more clear when I talk to you about representation of sets, but for the moment if we understand that sets are represented by a capital letter. Also, if we want to say that a particular element belongs to a set, so we can say A belongs to A. So, it is very clear from here that A stands for element, that is the small alphabet which indicates the element, and belongs to capital A here indicates the set A. So, there is a very clear demarcation which will help you understand what is the element and which is the set. Let us move on. So, there are two ways of representing a set. The major two ways are the roster form and the set builder form. The roster form, we enclose the elements within a curly bracket and the elements are separated by commas. As you can see here in this example, odd numbers less than 10. So, you can see 1, 3, 5, 7, 9 and it would be the set would be demarcated by a capital value, capital variable, and the elements inside would be separated by commas and enclosed within curly brackets. So, this is how the roster form of set is represented. Suppose if we take a very novel example, the set of all the letters in the word coronavirus. Okay, you can see the word here coronavirus, it is given by any alphabet can represent a set, but please see that it is represented by a capital letter. Now, since I have spelled coronavirus in capital, so the elements can be in capital. So, it is enclosed within curly brackets and you can see a small difference here that O is coming twice here in coronavirus, but it has been written only once in the roster form. So, roster form has a rule that generally the alphabets which get repeated or the elements which get repeated do not find the representation in the roster form of representation, meaning to say that if O gets repeated, so it will be represented only once. So, that is how the alphabets are separated by commas, and if the alphabets get repeated, it would be only represented once. So, this is the roster form of representing sets. in the set builder form, all the elements are defined by a common property which runs through all those elements in a particular collection, which is well defined. For example, if we take here, suppose a set is there 1, 2, 3, 4, 5, 6, 7, 8, 9, which is given in roster form, and you want to convert the same thing into set builder form. So, that can be written as x such that x belongs to n. So, what is n? N is natural numbers, and such that you are demarcating n and n is less than 10. So, two conditions here apply: x such that x, it has to belong to a set of natural numbers wherein the natural number is less than 10. So, you can see the roster form exactly the same is converted into a set builder form. So, we move on to the types of sets. So, the first type of set is the empty set. Now, what is an empty set? I will try to explain you with an example. Suppose if you want to have a number which is both even and odd, which is that number which comes to your mind which is both even and odd? There is no such number which can be both even and odd, and that kind of set can be represented by a null set. So, how do you denote a null set? You can see here I have just drawn two curly brackets and there is no element. So, either it can be denoted by an element called as phi, or just enclose it within curly brackets like nothing and just a plain curly bracket. This also shows that it is an empty set. But mind you, if you have anything within curly bracket like a 0, phi, then it is not an empty set. So, that is the difference. Okay, I hope that is clear. The second type of set which I would like your attention to be is the singleton set. So, as the name indicates, singleton set, that means definitely the set will have one element. Okay. Now, the question or the example which will come for this case is like a even number which is also a prime number. Okay. Which is that number which comes to your mind? I guess all of you might have got it right, and the value is 2. So, any set which has got only one element is called as a singleton set. Okay. And we will keep figuring it out through a lot of examples. You keep solving, you will understand better, meaning to say that if there is only one element inside the set, it is a singleton set. The next one is finite set. Now, what do you mean by finite set? If the number of elements are countable, if you have number of elements inside a set which is countable, it comes in the category of finite set. For example, if I say what are the first 5 multiples of 5? What are the first 5 multiples of 5? What will come to your mind? Okay, you all got it right. So, it is 5, 10, 15, 20 and 25. That is absolutely right. So, do you see that the elements inside the set is countable? So, if it is countable, it is part of finite set. Now, what is infinite set? Just the opposite of that. If the elements are not countable, if we cannot count the elements inside the set, it becomes part of infinite set. So, what comes to your mind right now? Yes, many of you have guessed it right. So, you can say a set of natural numbers is infinite set. For example, 1, 2, 3 and it is endless, it goes on. So, it is a infinite set. So far we were discussing about a type of set. It could be null set, which is also called as empty set, finite set, infinite set and also singleton set. What about if there are two sets? So, two sets either can be equal or cannot be equal. So, we will just see when are two sets equal. I will just try to give you an example and then you will understand. Suppose A is 1, 2, 3 and we have another set B which is equal to say 3, 2 and 1. You can see that elements in both the sets are same and even the number of elements are also same. In this case, set A and set B are equal and we can write it as A is equal to B. I hope it is clear. So, let us understand what is equivalent sets. Two sets are called as equivalent sets when the number of elements in the sets are same, but the elements in themselves are not the same. I will give you an example. For example, you have set A as with elements 1, 2 and 3 and elements in set B could be 2, 3 and say 6. You can see that the number of elements in both the sets are 3, which is also called as the cardinal number, and it is represented as NA. NA is also 3 and NB is also 3, which is known as the cardinal number. So, the cardinal numbers in equivalent sets are the same, but the elements themselves are not the same, meaning to say that all the elements are not the same. Such sets are called as equivalent sets. Let us move on to understand the concept of subset. To help you understand the concept of subset, let me draw a similar meaning like word which is subordinate. So, when you talk about subordinate, it means that you are under somebody. So, subset also has a similar meaning, if not exactly the same meaning. So, here I would like you to have your attention on a set Y is said to be a subset of X if every element of Y is also there in the set of X, and we write it as Y is a subset of X. Y as a subset of X. So, this is the symbol of subset. We write it as a C and a equal to sign underneath. This is the symbol of subset. Now, just the opposite is the superset. If Y is a subset of X, so X is a superset of Y. So, just a very similar understanding. For example, I will take an example like set A is equal to 1, 2, 3, 4 and 5. Okay, and set B is equal to 1, 2 and 3. So, you can see all the elements of set B are there in set A. So, which is a subset of which? You can say B is a subset of A. If B is a subset of A, then A is a superset of B. Okay. I hope it is clear. So, that is the meaning of subset and superset. For example, let us talk about a very current example of coronavirus. Now, this coronavirus is from the family of virus. So, we can say coronavirus is a subset of the family of virus, and virus is a superset of the family of coronavirus. I hope it is clear, because it is a very current example which is going on right now, and we all are facing this pandemic. So, it will be more clear when you connect it with the current happenings. So, the example I cited was coronavirus is a subset of the family of virus. This example is happening in our recent times, and you can imagine further that yes, coronavirus is a subset of the family of virus, and which is a superset? The superset is the family of virus. Now, moving on from the concept of subset and superset, we move on to the concept of proper subset. Now, what is proper subset? Proper subset means the element in the subset should be 1 or 2 less than the elements in the set. Okay, let me draw your attention to an example. Suppose set A is equal to 1, 2, 3 and set B is equal to 1, 2, 3 and 4. Now, you tell me whether A is a subset of B or A is a proper subset of B. In this case, we can say A is a proper subset of B. The reason being, A has elements, all the elements of A is there in B, whereas there are few elements in B which are not in A. So, you can say A is a proper subset of B. Whereas, if you have another set like C is there, wherein you have sets as 3, 2 and 1. If such two sets are there, then you can say that A is a subset of B. This brings us to a very important conclusion that every set is a subset of itself. Another important conclusion is every null set phi is a subset of itself. So, these two important conclusions are there, and you would draw some conclusions on your own when you have more understanding developed in the same concept. Continuing with power set. Now, what is power set? The set of all the subsets is called as the power set, and generally the formula to calculate power set is 2 to the power of n. Okay, we will take up an example later to help you understand how do you calculate power set. Let us understand some operations on sets, and the first operation on set is called as A union B, that is also called as the union of sets. Okay. Now, I have already told you A union B. Suppose I give you an example, set A is equal to 1, 2 and 3, and there is another set B, say 3, 4 and 5. Okay. Now, if I want to find the union of the two sets A union B, it is indicated like this, A union B, and you can enclose it within small brackets. Bring together all the elements of set A and B, but then please note it that you are counting it only once. So, you can see that element 3 is getting repeated in both set A and set B, but you will denote it only once in A union B. So, here you will write it as 1, 2, 3, 4 and 5. So, this is A union B. So, if we want to understand it algebraically, it is also written in books like X belongs to A union B. This indicates X belongs to A or X belongs to B. Please remember a very important word here, or. So, or is a word which will help you understand that it belongs to the operation of unions. And if X belongs to A union B, if you have an understanding, you should also understand what do you mean by X does not belong to A union B. So, X does not belong to A union B, meaning to say X does not belong to A and X does not belong to B, or X does not belong to B. Okay, that is the meaning of X does not belong to A union B. And the Venn diagram, which we would later discuss also. So, this is the Venn diagram, and this is how it is drawn, and this is set A and set B. There might be some common elements between A and B. So, the common space is for the common elements between, and otherwise A union B is denoted by the shaded portion in set A and set B. So, that is A union B. I hope the concept is clear to you. We move on to the concept of intersection of two sets. Suppose you have two sets, set A and set B, and in set A you have all the vowels A, E, I, O and U, okay, and in set B you have all the consonants. So, it is B, C, D and so on, okay. What can you say, what is A intersection B? You can see that there is no element which is common to both A and B. In this case, when there is nothing common between both the sets, you call it as phi. There is nothing common and you denote it by phi, or you can even denote it by just curly brackets, nothing inside, which we had already discussed prior to this. So, this is how it is denoted, A intersection B. Now, this is how it is denoted, intersection and inverted U, and this stands for AND. Okay. So, it has to have common elements in both the sets, set A and set B. So, let us take another example. Suppose set A is equal to 1, 2, 3 and set B is having elements 3 and 4. So, what is A intersection B? A intersection B, you can see what is the common element between A and B. The common element between A and B is 3. So, A intersection B will have 3 as a common element. And do you remember what is this type of set called as? Yes, this type of set is called as a singleton set because it is having only one element, right. So, this is intersection, and please remember the symbol, it is denoted by an inverted U, and this means AND, it has to be common between both A and B. Now, if I denote it by using algebra, X belongs to A intersection B, it stands for X belongs to A and X belongs to B. And if it does not belong to A intersection B, it means X does not belong to A or X does not belong to B. Okay, let us understand some more terminologies. Suppose disjoint sets. Now, what are disjoint sets? The name itself indicates some things. So, disjoint sets means there is nothing common between two sets. Such sets are called as disjoint sets. And how do you denote it? So, you can see there are two sets which have nothing in common, and in Venn diagram we would represent it like that, and A intersection B would be equal to phi. Okay. So, such sets are called as disjoint sets. Now, we will understand what is difference of two sets. What do you mean by difference of two sets? A minus B. So, there would be certain elements which are only in A but not in B. A minus B. So, it will be more clear if I depict it pictorially. Suppose there are two sets A and B with some elements in common. So, A minus B would be denoted like this. only in set A but not in B. So, this shaded portion over here indicates A minus B. Okay. Then if you want to understand, the next important terminology and the concept of set is complement of set. What do you mean by complement? Let us take the literal understanding of the word complement. Complement means what is not there in me but is there in my partner, that is called as complementing. So, similarly, if you understand what is complement of a set is, what is not in A but is there in the universal set, that is complement of set. Suppose if you have a set A and this is the universal set, so everything beyond set A is A dash. So, what is not in A but is in the universal set is A dash. Suppose let us take an example. Suppose the universal set is a set of 5 elements and I will just plainly take the first 5 natural numbers. So, it is 1, 2, 3, 4 and 5. This is the universal set, and set A is the first 3 odd numbers. So, it is 1, 3 and 5. What do you say? What is A dash? So, A dash, as I told you, what is not there in A, what is not there in A but is there in the universal set forms the complement set. So, what is A dash? So, it is simple, it is 2 and 4. So, this is a complement. I hope you have a very clear understanding of all these concepts beginning with complement of set, disjoint sets and difference of sets. So, let us understand a very important law which is called as the De Morgan's law. And what is De Morgan's law? A union B whole dash is equal to A dash intersection B dash. Also, the second law of it is A intersection B whole dash is A dash union B dash. So, after understanding all these concepts on sets, it is time that we take up a question to check our understanding. So, let us take up a question. We have the universal set denoted by U and we have elements in it from 1 to 9. Okay. And then we have set A as 1, 2, 3, 4, set B as 2, 4, 6, 8 and set C as 1, 4, 5, 6. So, these are just simple examples for you to understand. I will take up first 4 options to solve. Now, first one is A dash. What was A dash? A dash stands for A complement. How do you find A complement? A complement means all those elements which are not in A but are in the universal set. So, what is A dash? A dash will come to, in the set A we have 1, 2, 3, 4, that means A complement will have 5, 6, 7, 8 and 9. So, this is A complement. B complement you will do it on the similar lines. I will take up B complement, complement of B complement, okay, that is option number D. The others for you is visible on the screen and I wish that you take up all these questions as practice exercise, and in the chat window when we upload the video you would have time and space to solve all these questions and give me the answers for the same. So, complement of B complement, let us first find out what is B complement and then we will find out complement of B complement. So, in the set B we have 2, 4, 6, 8. So, what is B dash? B dash will be 1, 3, 5, 7 and 9, that is B dash. Let us find out what is complement of B complement. Okay. So, what is it? You will get 2, 4, 6, 8. What do you conclude from here? You will have some conclusions, not confusions definitely, some conclusions, which is you can find complement of a complement is the set itself. So, very well it is noted, complement of B complement you will get it as set B. So, a very important conclusion we can make from this question is complement of a complement is the set itself. So, I will take up one more question and the question is the G option, B minus C whole complement. So, here set B is having elements 2, 4, 6, 8 and set C is having elements 1, 4, 5 and 6. So, what would be B minus C? So, this is the difference of the two sets. How do you find it? So, you have to find out the difference in two sets here. In this case B minus C, all those elements which are in B but not in C. So, find out from this question all those elements which are in B but not in C. So, what are those elements? It is very clearly 2 and 8. So, these are the elements which are in B but not in C. And what is the complement of it? B minus C whole dash. Complement of it would be all those elements apart from 2 and 8 which is there in the universal set. So, let us find it out. So, it would be 1, 3, 4, 5, 6, 7 and 9. So, this is B minus C whole complement. Moving on to the last concept in the chapter of sets, it is Venn diagram. And what is Venn diagram? Venn diagram is a pictorially explained positions of sets. It is very easy to understand and you would be able to attempt all the questions based on your understanding of Venn diagrams. A very important rule which emerges from the Venn diagram is NA union B is equal to NA plus NB minus NA intersection B. This one rule is enough for you to solve many questions based on Venn diagrams. Let us take up a very simple question and conclude today's lesson. Okay, the question goes like this: among 1000 people, 800 can speak Hindi and 500 can speak English. Okay, you have to find how many can speak both Hindi and English. How many can speak both Hindi and English? So, you can draw the clue from the word and. When you have the word and, it talks about finding intersection of sets. That is, how many of them can speak both Hindi and English. So, let us understand what is given in the question. So, what is given? 1000 people. So, we have NA union B is equal to 1000. What else is given? 800 people can speak Hindi. How do you denote that? NA. Suppose if you denote Hindi speaking people by A. So, NA is equal to 800 and 500 can speak English. 500 can speak English, meaning NB, suppose English speaking people are denoted by B. So, NB is equal to 500. Now, you have to find out how many can speak both Hindi and English. So, let us apply the rule which is NA union B is equal to NA plus NB minus NA intersection B. So, 1000 is equal to NA was 800, NB was 500 minus NA intersection B. Okay. Now, this is 1000 is equal to 800 plus 500 is 1300 minus NA intersection B. Solve it and you will get NA intersection B as 300. That means there are 300 people who speak both Hindi and English. And the same thing you can pictorially denote it like this. So, this is the common group which is 300. How many people can speak only Hindi? Only Hindi means they are Hindi speaking people are not speaking English in this case. So, 800 people were speaking Hindi. How many people are speaking only Hindi? That means we have to find this area. How do you find this area? So, this is 800 minus the common area which is 300. So, how many people are speaking Hindi? NA will be equal to 800 minus 300 is equal to 500. You can see around 500 people, exactly 500 people are speaking only Hindi. So, how many people are speaking only English? To find out this area, we are supposed to find out this area which I am indicating by dots. So, English speaking people are 500 in number and the common area we found out to be 300 people, those who speak both Hindi and English. If we subtract the English speaking people and subtract it by 300, we get it as 500 minus 300 is equal to 200 and we find out that number of people who speak only English is 200. So, what all we learnt in this module? We learnt about the concept of sets. Let us just recap the concept of sets. A well defined collection of objects is called as sets. Example we cited as the number of Marvel movies a child has got. Collection of Marvel movies is called as a set. Another example could be number of girls in a particular class. Say number of girls in 11th A is called as a set. But if we say the most beautiful girls in 11th A, will that form a set? No. that won't form a set, because in this case it is not well defined. A girl may be beautiful to one but may not be beautiful to the other. So, it is little dicey. In this case, when we are not defining it well, that collection of values is not called as a set. Then we went on to discuss about the representation of sets, and we have concluded that there are two ways of representing the sets. One is the roster form and one is the set builder form. Also, we looked into the types of sets. We have defined the various types of sets like null set, singleton set, finite set, infinite set, equal sets and equivalent sets. Moving on, we have also learned about subset, superset, power set and various other components of sets. Also, we have learned about the operations of sets. Majorly, we have worked on the complement of set, the union of set, intersection of sets, and we have solved few questions with the help of Venn diagrams. Hope this module helps you with a good concept of sets and you would learn more and grow in your understanding of sets.